Hello students, myself Ambika Inni, Assistant Professor, Government Engineering College, Ramnagar. Today we'll be discussing about the SR flip-flop. Before going to explain the theory of the SR flip-flop, these are some of the prerequisites. It's already you are aware in last session. This is the Verilog syntax that how to we need to write a program, that is module name, port list, port declaration, data type declaration, module functionality or structure, end of the module. So always you need to remember this Verilog syntax properly, and these are the steps how to execute the programs in a Xilinx platform. So experiment number 5B, that is to write a Verilog code for SR flip-flop circuit and its test bench for verification. Observe the waveform and synthesize the code with the technological library with the given constraints. And these are the objective. You have to aware how to write the Verilog code for the given circuit. For this circuit, observe the recorded waveform, synthesize and see the RTL schematic. So this is the theory about SR flip-flop. So SR is also called as set and reset flip-flop. Q and Q bar are the outputs. So this is the internal NAND latch circuit for the SR flip-flop. It can be seen that when both the inputs are high, the output Q and Q bar either or depending upon the state of the S input or before. The input condition is therefore the condition SR1 does not change the state of the output to be Q and Q bar. However, the input state of S is equal to 0 R is equal to an undesirable or invalid condition must be avoided. The condition of S is equal to R is equal to 0 causes both outputs Q and Q to be high together at a logical level 1, when we would normally want to Q to be the inverse of the Q. So the result is that flip-flop loses the control of Q and Q, and if the Q of the two inputs are now switched to high, again after this condition logical 1, the flip-flop becomes unstable and switches to an unknown data state based on the unbalance as shown in the following switching diagram. So this is the program what we have for the SR flip-flop module name, and these are the set of the inputs, that is S, R, clock, Q and Q bar input, output and inbuilt registers. Always at positive edge of the clock begin if S is equal to 0 and R is equal to 1, Q is assigned to 0. Else if S is equal to 1, R is equal to Q is also assigned to 1. If 0, Q is assigned to Q, the previous value. Else if both are complemented value, it will be assigned in a high impedance state, because for both the values we are getting a unknown value. That's why we need to assign it in a high impedance state. And to get a complemented value, finally in concurrent statement, Q is assigned to not of Q. And here in test bench we are giving a set of values with a delay with clock for the S and R inputs. So once we execute the program, this is the output what we are getting. So here in result we have verified the SR flip-flop circuits and its test bench for the verification. So this is the learning method. Management systems organized by Karnataka. This e-content moderator is Rashid Prasad, and myself e-content developer Ambika Inni. So once this is done, go to how to execute the SR flip-flop. So go here in desktop, you have a double Xilinx. Double click on that Xilinx tool. It shows the tip of the day. Just say OK. Go to File, Close Project, File, New Project. So write the program name. Go to Next, Finish. Next, go to Project, New Source, Verilog module. Next. So here also you can define the input and output port, but for demo purpose we'll leave it there only. Okay. So for this also we take executed program, that is SR flip-flop. So once we edit, if some error is there, it takes a long process. So that's why I already executed, and that program only I'm taking for a execute purpose. But once you're doing, you need to write yourself and see if error is there. Just remove that error and then go to check the write the test bench. Okay, once the program edition is over, just save this and go to implement synthesize XST, check syntax. Next go to, after this check syntax is with the green tick, select this new source, Verilog text fixture, and here you give the name SRFF78 underscore TB. So this is the test bench program. So test bench values also will feed the test bench values. So in test bench program we will be giving a input set of inputs to check the output. After for this also we say to simulation, select this ASC simulation, simulate behavioral model. So this is the output what we are getting with respect to the, so clock is not there, R is not there, that's why it is will be in high impedance state. And with respect to the whatever the value is there, so with respect to that we will be getting an output. So here with respect to the rising edge of the clock and RST is high, and whatever is there with respect to the value of S and R, when S is equal to 0, R is equal to 0, the value will be 0 because S is 0, set is 0. Next, for the next rising edge of the clock, S is now clock is high, S is 0 and R is 0, the output is also 0. For the next value, when S is high but clock is 0 here, so with respect to this, when clock is high, S is 1, Q is 1, that is a set condition. Next again it will be followed same, and next for clock is 0 it will not work, and it will be in a high impedance state. Okay, so we can check the previous value and the set condition, reset condition, and the high impedance value. When both the values are 1 1, we have given a high impedance state. So this is how we can verify a program for a SR flip flop. Okay students, thank you. We'll meet in the next session.